Morning, everybody. Today we're going to be looking at an introduction to the normal distribution. And basically when we're talking about this thing called the normal distribution, we are talking about curves, we're talking about data that if you trace the points here is roughly going to look like a bell curve. It's going to look like a symmetric bell curve. So anytime you hear me using the word normal distribution, we're going to be talking about this shape right here. Now, the reason that we're going to be talking about normal distributions are that they are very, very common distributions that we see in life. And so basically, normal distributions occur when many different factors affect the value of a specific variable. So some examples of normal distributions here. We've got the height of 16-year-olds. There are a lot of variables that could affect the height of a 16-year-old. If you think about the yield of corn and wheat, so like how much corn and wheat are being produced in a year, there are a lot of factors that could affect that value of that variable. The lifetime of batteries, there's a lot of things that could affect that value of a variable. Weight of peaches or other things would be normally distributed, but those are just a couple of examples to give you all an idea of the wide range of the normal distribution here. So the way that we need to think about this, or some vocabulary real quick. So we have the mean here. So the mean that we represent with this symbol mu measures the center of the distribution. So like right where your center of this curve is right here, we've got mu, which just says the mean is, it kind of anchors it. Everything else goes from there. So then the standard deviation here measures the spread of the distribution. And so basically when you have a normal distribution, we're listing things in order of how far away from the mean are they. And we quantify that by how many standard deviations we are. So if you go to the right, you add one standard deviation. So every step you take, you're adding another standard deviation here. And I'm a little short on room here. But basically you want to go out and add or subtract 3 standard deviations both ways. So that concept of standard deviation that we talked about last class is going to tie in very, very closely into the normal distribution. There's a reason we're going in the order that we are with this stuff. So the notation that you all are going to see to indicate a normal distribution, some things that the notation we need to recognize here. If you see this x, we read this as x. This symbol right here, we read this as is distributed. And then the N stands for normally with a mean of mu and a standard deviation of whatever that is. Whatever the standard deviation is at that moment. So that's just kind of a vocabulary introduction there. Nothing crazy there, but the actual math that we're going to get here is going to come from 12b. So I don't know if I wrote this in your all's, I don't know why I have 12b written down actually. That needs to say 15b. That's a big Mr. Price issue. My fault there. That should be 15b. I don't know why I wrote 12. So basically so this right here is a standard normal distribution curve. Every normal distribution that we're going to draw in here is going to look something similar to this. So if we know that a distribution is normal, every normal distribution follows this pattern right here. So you have the mean right here, and from the mean to the first standard deviation to the right or the first standard deviation to the left, those are both 34.13%. So this is a picture that we need to draw. We need to have somewhere in our notes to reference, because we can get a couple of rules from this. And basically it's called the 68, 95, 99.7 rule. And what that says is that 68% of observations are one standard deviation away from the mean. So if you add those two numbers right there, we'll get 68.26, but it's approximately 68. So then are one standard deviation away from the mean. So then the two standard deviations away here, two standard deviations away, if you go out 1, 2 steps in both directions here, 1, 2, 2 standard deviations away, and you add up these four numbers right here, 95% of observations are going to lie within 2 standard deviations of one another. 95%, which is a substantial amount. That would be basically everybody in this class except for one person. And then the last one here is that 99.7% of people are within 3 standard deviations of the mean. If you're not within 3 standard deviations of the mean, you're getting into some pretty rare territory. Some pretty rare territory there, because you're a part of the 0.3% of people that are not. So we're talking a serious outlier in one direction or the other. So we need to make sure we have this picture down. We need to make sure we have these percentages written down, because we are going to be using some properties of the normal distribution to answer some questions about a wide range of problems. So get that down for me, and take a second if you need to, and we're going to do some math problems here with this. Now, basically, if you have any variable that's normally distributed, if you can figure out that it is normally distributed, or if you are told that it is normally distributed, you can use the mean and the standard deviation to estimate a proportion within an interval. So more practically, what that's going to look like here. So in example 1 here on page 367, we're told that a sample of cans of peaches was taken from a warehouse and the contents of each can was weighed. The sample mean was 486 grams with a standard deviation of 6 grams. So whenever you're dealing with a normal distribution, the very first thing that we're going to want to do is draw our curve here. So here's our normal distribution. We've got the mean that's going to be right in the smack dab in the middle of this thing. And each standard deviation, if it's 6, if we go to the right, we're going to add 6 to it. So this would be 492. This would be 498. This would be 504. And then going the other way, 486 minus 6 is going to give us 480, 474, and then 470. We really only need to go out 3 each direction, because past that point, there's only 0.3% of observations. So I'm just going to draw these dotted lines real quick and write in those percentages. So we know this one's 34.13, 34.13, 13.59. These differ just a little bit from the percentages that I use for my statistics class, which is perfectly fine. I've just got to get used to them very quickly. So 0.13%. They usually vary just a bit depending on which source that you use, and that's okay. So now that we have this drawn, we want to say, okay, what proportion of cans weigh between 480 and 486 here? So between 480 and 486. So we want to know what percentage of observations here lie between those two. So looking at that, you're probably just like, well, Mr. Price, that's kind of obvious, man. Like, why are we going over? It's 34.13%. And because it's normally distributed and it's once we have this curve drawn, really all that we've got to do is look and say, okay, well, what are we trying to find? And then let's add those if we need to. So then more than 492 grams, if I draw a line here at the observation of 492, I've got to add all of that stuff there to the right of it because we want to know more than 492. So we're going to add 13.59 plus 2.15 plus 0.13, and that should give me 15.87%. So the probability that a can weighs more than 492 grams here is going to be 15.87%. If we know that it is normally distributed there, then we can say, okay, well, let's draw this curve and let's go from there. So we're going to look at one other example for a normal distribution today. So this is example 2 in your all's book. That's on page 369. So for we're looking at the chest measurements of 18-year-old male rugby players. They tell us that those are normally distributed with a mean of 95 and a standard deviation of 8. So the very first thing before we do anything else is I'm going to go ahead and just draw a curve here. So let's see. The mean is 95, so we're adding 8. We've got 103, 111, 119. We've got 87, 79, 71. And then we can talk about 34.13, 13.59, 2.15, 0.13, 13.59, 2.15, 0.13. So now that we've got this curve drawn right here, we want to say, okay, from a group of 200 18-year-old male rugby players, how many would you expect to have a chest measurement between 87 and 111? So I'm actually going to move that up just a little bit. So the first thing that we need to do is figure out how many of those people are between 87 here and then between 111. So between these percentages right here, so we're going to have to add those together to figure that out. So for A here, we do 34.13 plus 34.13 plus 13.59, and that is going to roughly give us, adding that together, about 81.85%. Now, the thing is here, the question asked from a group of 200, roughly how many would we expect? So what we're going to have to do is find 81% of 200. We're going to have to multiply 200 times 0.8185, and then whatever that number is, 81% of 200 is going to tell us the amount of people that we could expect. This is normally distributed, so times 0.8185, that's going to be roughly 163.7, which we're going to call 164 people. We're going to call that roughly 164 people here. So then for B here, we want to find the value of K such that approximately 16% of chest measurements are below it. such that 16% of chest measurements are below it. So think to yourselves real quick, how could we figure that out using this curve right here? About where would the bottom 16% be? Think to yourselves real quick about that. So give or take, it's going to be this part of the graph right here, because if it's going to be the bottom 16%, it can't be, you can't include any of this 34 stuff. We'll count everything to the left of it. So if you add up these percentages right here, you end up just a bit shy of 16. But this mark right here will give you the coordinate there. So that coordinate, or that data point rather, is just going to be 87 centimeters. And we'll say for the bottom 16%, or the 16th percentile. So that is all that I have for you all today on normal distributions. What we can do is, if you all have any questions, please ask on the Zoom or shoot me an email, and we will go from there. Thanks.